This is the 6th video presentation for the CASE Plant Science course. As you view this video, make notes of important information. Pause, repeat, and resume the video whenever necessary. The problem with pH, Lesson 2.2, Soil Chemistry. You recently completed Lesson 2.1, Understanding Soil Properties, learning about the physical properties of a soil. Now we will begin exploring the chemical properties of a soil related to plant growth. This presentation is an overview of general pH principles and how pH is important for soil chemistry. This basic overview will help students with Activity 2.2.1. What is the pH problem? pH measures hydrogen and hydroxyl ions in a material. The net charge affects how the material interacts with other materials. Sweet and sour are traditional terms used to describe acid or alkaline soils. At one time, agronomists, soil scientists, and farmers would taste the soil to detect these characteristics. Today, very simple and inexpensive testing devices are used to measure the exact pH to determine soil management decisions. Distilled water would be an example of a pH-neutral substance. 1 full point on the pH scale represents 10 times more acid or alkali, depending on the direction of the difference. Let's try a pH calculation. How many times more alkali is 9 from 6? 3 full points difference is calculated as 10 times 10 times 10, or 10 to the third power. This calculates the difference between 6.0 and 9.0 as 1,000 times more alkali. pH is a consideration for any plant production industry. pH will determine plants' fertilizer use for optimal growth. If pH is not optimal, many nutrients added will not be utilized for plant growth and health. The plant producer then risks the loss or leaching of valuable nutrients to the environment. In the figure, the thickness of the bar indicates the range for availability of nutrients for plant uptake at that pH level. The thicker the bar, the better the nutrient availability. The chart shows a range of approximately 6 to 8 as optimal for the highest nutrient availability. Notice how nitrogen becomes less available for plants starting at pH 5.5 and pH 8.5. Soils with a pH level below 4 and greater than 10 will not support many species of plants. The pH and nutrient availability diagram can also be found in your text for future reference. You will explore more about scientific plant nutrients and the relationship with pH in Lesson 6.1, Plant Food. Plant producers often use soil amendments to adjust pH levels to ensure optimum nutrient availability. You will explore buffering and correction of soil pH in Activity 2.2.2, Correction of a pH Problem. As a review, mark or highlight 3 key points in your notes that are important to remember from this presentation. List 2 ideas or concepts that relate to previous knowledge. List any questions you have about this topic. Discuss these questions with your instructor. Keep any notes that you have from this presentation organized and available for use throughout the course. Through Activity 2.2.1, you will conduct a soil sample test to determine pH. This will help you understand that soil pH determines the availability of nutrients required for plant growth and health. Your instructor will share where to find the materials and soil samples required to complete the activity. During this lab, you'll be using the Vernier LabQuest 2 and pH sensor.
This is the pH sensor, and it's used to measure the pH of a solution. To use this, you need to take it out of this storage solution, and this is a pH 4 buffer solution that keeps from damaging the sensor. So you want to make sure that you always store it in the solution To use this, we need to take it out, so I'm going to unscrew this cap, and as I do this, it loosens this gasket. I'm going to pull it out, and now I'd be ready to use it. Now, the active part of this sensor is this glass little globe down here, and so that must be in contact with the solution that you're trying to measure the pH. To use it, you're going to take it and just make sure that's immersed in a solution. The first thing I need to do is to plug this into my LabQuest. So it goes into one of the analog ports here. And when I plug it in, I end up getting my meter reading here. And it's close to the 4, where I had it in the solution before. So I have a solution here, and we're interested to know what kind of solution that is. So maybe I plunge it down in there, and we look at what happens to our meter value there. So it's climbing, so it must be a base. And so it's stabilized about there, so 11.2 something there. So it's obviously a base. Now, to put this away, I need to make sure I clean it. So I have some distilled water here, so I'm just going to kind of rinse that off to clean that up. And then I will put this back into my storage solution.